Hello, all my dear students. I welcome you all to Chakra Academy, where every minute of your time will help you learn some new concepts and enhance your subject knowledge. So, our today's topic is basically on finding the time period of a simple pendulum under different cases. See, for finding the time period, what is the most important thing you need to find out? For finding the time period of a system doing SHM, first of all, we need to look out how to find the restoring force. The moment you find the restoring force, the next step is you need to find out the omega. The moment you have omega, you know that time period is 2 pi by omega. So if you see the question on the board, in this question, we have been given the expression for the potential energy, which is k times of x cube, where k is a positive constant and a is the amplitude of the oscillation. You need to find out time period is connected to the amplitude in which manner. First option proportional to 1 by root a, second independent of a, third proportional to root a, and fourth one proportional to a to the power 3 by 2. So here we need to use the fundamentals of mechanics also. Since we know F is equal to minus of derivative of potential energy with respect to position. We have studied this in work power energy chapter. I hope that all of you remember. F equal to minus du by dx. So what is potential energy given to us? Kx cube. Let's differentiate. So k will be as it is. What is the differentiation of x cube? It is 3x squared. So this is our force. If you remember, the force acting on a particle doing SHM is minus m a, where a is basically, it's not minus ma, it is m into a, where a is minus omega square x. So you will put a as minus omega square x, which is equal to minus 3kx into x. I just try to write in this manner only. So we can cancel minus minus x. What is omega square equal to? 3kx by 1. So omega will be equal to square root of 3kx by. Now you can clearly see here, omega is directly proportional to square root of x, correct? You can clearly see. And what is x? What is displacement for a particle doing SHM? A sine omega t, initial phase is 0, right? So we know that x equal to a sine omega t. So it means that omega is directly proportional to root a. Since omega is directly proportional to root of x and x is directly proportional to it, it means omega will be also directly proportional to square root amplitude. Now we need to find out the relation between amplitude and time period. Now how is omega connected to time period? Time period is 2 pi by omega. So time period is inversely proportional to omega. It means time period will be inversely proportional to square root of a also. So which option looks correct, students? Option A, proportional to 1 divided by square root of the amplitude. I hope that you guys have understood. It's a very beautiful question where the concept of F equal to minus du by dx is connected with SHM. So let's move to the next question. Okay, students, as you can see the next question, here the question says that a simple pendulum has a time period T1. Point of suspension, the point from which pendulum is connected, the point of suspension is not stationary. The point of suspension is basically moving up. So find out the ratio of T1 square and T2 square. And the point of suspension is moving in which manner? KT square. Right? The point of suspension is moving in this manner or according to this equation. So let's solve this problem. So in this question, what we will do? First of all, we will find out acceleration with which the point of suspension is moving up. So y is equal to kt square. Find dy by dt. That is the velocity of the point of suspension, which will be what? 2kt. What will be the acceleration? Differentiate it again. So d square y by dt square, which is 2k. So this is the acceleration. Double derivative of position with respect to time is acceleration. What is k given to us? 1. Acceleration is basically 2 meter per second square. So what they are explaining to you here is that point from where the pendulum is attached, the point is moving up with an acceleration of. So when we write down the expression for the time period of a simple pendulum, 2 pi under root L by G. All of you understand that this G is basically the net acceleration. G is the net acceleration. So if you see that G always acts in the downward direction, but the point about which pendulum is fixed, that point is moving up. With what acceleration? A. So if you think of the concept of relative motion, what is the effective acceleration? G effective will be equal to G minus of minus A, which will be G plus A. So what will be the time period? This is our original time period, T1. What will be T2, students? 2 pi under root L divided by G plus A. Correct? This is T1 and T2. We need to find the ratio of T1 square and T2 square. So first of all, divide them. So when you divide T1 and T2, what you can notice, when you divide them, T is inversely proportional to the acceleration. So it will be square root of G plus A divided by G. All the other parameters will get cancelled. L will get cancelled. 2 pi will get cancelled. So what will be G plus A? 10 plus 2, 12 by 10. So this is what? Square root of 6 by 5. You need to find the square. So when you square them, T1 square by T2 square, what will you get? 6 by 5. So if you see the option, it is option C. So you can see that last question and this question, the questions are not straightforward. But if your fundamentals are clear, they can twist the question, but fundamentals are clear means you can arams and manage in any type of situation. You just need to be calm, composed, and back your basics. Basics with good speed. That's the most important thing. Let's take one more question, last question on this topic. Okay, students, if you see that this question is basically not with the change of the acceleration. This time the length is changing. In the previous question, if you remember, acceleration due to gravity or net acceleration. This time the question is connected with the change in the length. So let's solve it. So let's write down the formula first. It is 2 pi under root L by G. So you can say that this is the initial situation when the length is L. No, the length is increasing by 21%. So what is the new length? New length will be 1.21 times of original length, right? Because it has increased by 21%. So this will be the new length. Now, what will be the new time period? Everything is same except length. So this will be 1.21 times of L divided by G. Let's divide both. So we need to find out time period increases by what amount. So if I divide T2 and T1, what will happen? Everything will get cancelled except the length ka factor. So 1.21 L divided by L. So this gets cancelled. What is the square root of 1.21? 1.1. From here we get T2 equal to 1.1 times of T1. So we got the relation between the new time period and the original time period. Correct? So if you see here, T2 is 1.1 times of T1. So how much percentage it has increased? 10%. Correct? 1.1. So what can you write down? If you're still not clear, you can write this as T1 plus 0.1 times of T1. Right? What is 0.1? 10%. Correct? So which option? If you see carefully, it is option B. Right? So I hope that you have understood the concept what we try to explain in the class. In the class, we make sure that you understand how to find the time period of a simple pendulum or any system doing SHM in different situations. So I want you guys to share this video with your friends and classmates, and do let me know in the comment box which new concept you want me to take in the next video. So do study properly, and I am with you. See you in the next session.